Hello, everyone. My name is Xijun Shi. I'm an assistant professor at Texas State University. First of all, I want to thank ACI 555 for putting together this section. And today, I'm going to present our research topic titled Fracture Properties and Restrained Shrinkage Cracking Resistance of Recycled Steel Fiber Reinforced Cement Mortar. The work was done when I was a postdoc at Texas A&M University. I would like to thank my colleagues, Leonardo. He was a visiting scholar at Texas A&M University. He helped me with some experimental work here. And Dr. Zach Gracely, he was my postdoc advisor, and he helped me with my research a lot. And he also has been very supportive of my career development. Josh was our former PhD student. He developed the ring test. He modified the ring test and he helped me assemble the ring. And I also want to thank Jinan for providing recycled steel fiber for our testing. All right, so our research is to use recycled steel fiber from scrap tile to reinforce cementitious material. We all know scrap tile recycling has very significant sustainability implications. For example, in 2017, according to a report, around 4.2 million tons of scrap tile were generated in the United States. The unrecycled tile waste has been a problem because tile waste are non-biodegradable, they are also flammable, and they can leach toxic substance into the ground. So currently, about 50% of the tile waste are used as a tile-derived fuel, but some of the states, for example, such as California, are prohibited from promoting fuel-related use of tiles. Because of a significant sustainability implications, as well as a huge market behind scrap tile recycling industry is growing very fast. For example, we all know ground rubber has been successfully used for civil engineering applications. For example, pavement engineer, we have been using rubber modified asphalt concrete and rubber modified cement concrete for building quieter and more sustainable roads. And during the production of recycled rubber, the recycled steel fiber can be extracted. And by talking to a vendor, we found that around 15% of the recycled scrap tile can be, by the weight of the total tile waste, can be extracted. So if we do a simple math here, if we use 4.2 million ton multiplied by 15% by the weight, then the annual production of the recycled steel fiber can be 0.63 million ton. And assuming if we just using 16% by weight in reinforcement concrete, then we can produce 10.5 million ton of concrete annually. Therefore, so the question is, what does tile recycling do with recycled steel fiber? So unfortunately, the recycled steel fiber is conventionally sold as ready-to-melt steel. Because it is sold as recycled steel for making new steel products, the price of the recycled steel fiber can be 10 times cheaper than industry-made steel fiber. And also, life cycle assessment studies show that processing the recycled steel fiber consume less energy compared to the typical manufactured steel fibers. Therefore, we think recycled steel fiber can be a cheaper solution to fiber reinforcement for cementitious materials. There are some preliminary results in Europe, and the studies conclude that recycled steel fiber can be as effective as manufactured steel fiber as concrete reinforcement. However, in the United States, we did not see a lot of studies being done. So that's why we conducted our studies at Texas A&M University. So the objective of our study is to conduct a detailed experimental program to characterize various material properties of cement mortars reinforced by locally available recycled steel fiber from scrap tile in the United States. So in our study, we did a conventional mechanical property test, including the compression test and a split tension test. We also did evaluate fracture properties of the recycled steel fiber reinforced cement mortar using a newly developed semicircular bending fracture test. We also did a cracking resistant evaluation of the cement mortar under restrained drying shrinkage by using a customized ring test. So first of all, we collected the recycled steel fiber from the big tire recycler company in Houston, Texas. So unlike the industry-made steel fiber, recycled steel fiber samples contain several foreigner elements, including the residual rubber, the steel wire, and the tile texture, and also steel fiber. Another difference between the recycled steel fiber and the industry-made steel fiber is that recycled steel fiber has varying fiber dimensions. To characterize the fiber sizes, we collected 500 fiber samples, and then we measured the diameter and the length using a micrometer. And so for our samples, the average diameter of the sample we used was 0.32 millimeter, and the length of our fiber was 14.9 millimeter. And this gives us an aspect ratio of approximately 55%, 55. So another unique feature of recycled steel fiber is that recycled steel fiber has residual rubber adhered to the fiber surface. So for example, here I'm showing a CM picture we took in our lab. So you can clearly see the residual rubber adhered to the fiber surface. So the existence of residual rubber can have pros and cons. On the one hand, the residual rubber increases fiber surface roughness, which can provide an improved mechanical bonding between the fibers and also and the cement matrix. But on the other hand, if we have too much rubber in the system, then the rubber may alert cement hydration and create a very weak ITZ. Therefore, we determine the fiber content in our lab, and we use an ignition oven test by following similar standard to test asphalt bonded content for asphalt concrete. And essentially, we just put our samples in the ignition oven, and then we burn away the rubber at 526 degrees Celsius. Then we measure the mass difference before and after test. Then we determine our rubber content as 2.25%. So I want to note here, this value is not very high, which means our fiber surface is relatively clean. And then we did our mixed design, and we did a specimen fabrication in the lab. So for our study, we just use a cement mortar. We just evaluate cement mortar, and the cement concrete is our ongoing work. And for the water cement ratio, we use a 0.4 water cement ratio by mass. And we use a sand to cement ratio at 2.75. And we had two fiber content, which is 1%, 2%. And we also have a plain cement mortar without any fiber. And we did not add any chemical or mineral admixtures. And immediately after our mixing, we did a flow test according to ASTM standard C1437. And as we can see, the control sample had a 230 flow value, and by adding 1% recycled steel fiber, the mortar has a flow value of 203, and by adding 2%, the flow value reduced to 168. So we saw some reduction in workability, but still the workability was acceptable, and we did not have any problem mixing and casting our samples. And we also did a fiber dispersion quality test in our lab. So basically, we just made an additional cylinder specimen. Then we cut the specimen into different slices. by counting the number of the fibers on different cross sections, we can evaluate the fiber dispersion quality. So the total number of the fibers that appear on different cross sections was found to have a coefficient of variation that is lower than 3% for both the 1% and 2% recycled steel fiber reinforced mortar. And since the value is very low, we consider our fiber dispersion quality was good. And then we did a mechanical property test. We did a compression test to evaluate the modulus elasticity and also the compressive strength. We also did split tensile strength test to get the split tensile strength of our cement mortars. So here I show the results in these three graphs. So the first graph shows compressive strength versus fiber content. And also the second one is a modulus elasticity versus a fiber content. And the third one is a split tensile strength results. So the major conclusions here are that the effects of recycled steel fiber on the compressive strength and the modulus elasticity are marginal. And however, the percent increase of the split tensile strength, as you can see in this graph, can be up to 50% if we add a 2% recycled steel fiber in the mortar. And we found a comparative study, and the authors in this paper, they use a 2% manufactured steel fiber with similar size to reinforce the cement mortar, and their percent increase in the split tensile strength was only 37%. So note our improvement is 50%. Then we conclude that the using recycled steel fiber can improve the split tensile strength higher than the manufactured steel fiber, which means reinforcement effect of the recycled steel fiber is equivalent or even higher than manufactured steel fiber. So after the mechanical property test, we did a semicircular fracture test. So the ACB fracture test was developed by myself when I was a student at Texas A&M University. So the test can be used to test concrete fracture properties for the famous 2-parameter fracture model. Conventionally, we use beam specimen to test a concrete fracture test. However, making beam specimen is both labor and material intensive. Beam specimen also are very hard to extract from the field. Therefore, I developed the ACB fracture test. So to make our ACB specimen, I only need one 6x12-inch cylinder specimen. Then I can make a 12 ACB specimen out of the one cylinder specimen. So the initial notch size I used was 36 millimeter, which is half of the ACB radius. And the testing procedure is just the same as a relearn method using the beam specimen. So essentially, I just load the specimen to the peak, then I unload the specimen, then I reload the specimen again. So by using this loading and reloading procedure, we can extract the elastic behavior of the specimen. Then by using some linear elastic fracture mechanics, we can calculate the 2-parameter fracture properties for the 2-parameter fracture model. So here we are talking about the critical stress intensity factor and the critical crack tip opening displacement. So as we can see, by adding 2% recycled steel fiber, our critical stress intensity factor can be improved by 45%, and the critical crack open displacement can be improved by 58%. And we can also calculate the fracture energies. We have two fracture energies terms calculated using this procedure. The first one is initial fracture energy, which is a fracture energy dissipated within the fracture process zone, and the second one is a total fracture energy. So as we can see, by adding 2% recycled steel fiber, the initial fracture energy improvement can be up to 125%, and the total fracture energy can be up to 411%. Next, we can also calculate threat and tensile strength using the fracture properties we obtained using the equation here. which is based on the linear fracture mechanics. And so note in the bracket, the ratio is selected tensile strength divided by the split tensile strength we did. We tested for the same cement mortar and the same curing age. So we can see the ratio is always lower than 1, which means the select tensile strength is always lower than the split tensile strength. And this conclusion is in a very good agreement with size effect theory proposed by Bassan. So as we can see, okay, as we can see, by adding 2% recycled steel fiber, the theoretical tensile strength can be improved by 34%. The other test we conducted is a ring test. The ring test is an effective test to evaluate concrete cracking resistance under restrained shrinkage. In this study, we use a modified ring with a higher degree of restraint to shorten the specimen cracking time. The result is showing here. So a sudden drop in the strain in the steel ring indicates the specimen has been cracked. So as we can see, by adding 2% recycled steel fiber, the cracking time, the average cracking time is 6.16 days, while the reference sample crack as around 4 days. So the improvement in the cracking time is 50%. And also we can see the recycled steel fiber has higher peak strain and higher residual cracking strain, strain after major cracking due to the fiber bridging effect. So this result shows that the recycled steel fiber has a much higher cracking resistance compared to the normal concrete cement mortar. So the conclusions adding 2% recycled steel fiber shows margin effects on compressive strength and Young's modulus of the cement mortar. But it has 50% higher than of the split tensile strength than the control mortar. And we think the reinforcement effect of the recycled steel fiber is similar or even higher than the normal manufactured steel fiber. By adding 2% recycled steel fiber, the fracture properties can be improved significantly, and also the fracture energy can be improved significantly. And by adding 2% recycled steel fiber, the cracking time was delayed by 50%, and also the pre-crack strain can remain 50%, 55% even after major cracking. With that, I think I can conclude my presentation. I'm open for the question.
Thank you very much. We have two people asking questions. The first one is Al-Khadir Al-Khalil. He's asking that he thanks you for awesome presentation, and he's asking you if you measured the workability or any results about that, and what instrument did you use for the workability. This is part A. Part B, he's asking if you have any opinion about the chloride ion diffusion of these specimens.
Okay. Yeah. So for the workability, we did not do a very extensive study. We just did a flow test, and we also kind of visually inspected our specimen, and we did not see any problem mixing and casting the specimen. So we think the workability was good. So the only test we did is ASTM standard 1437 using the flow table. And but we did a fiber dispersion quality to verify the fiber was well distributed in our specimen. And for the chloride, yeah, for the corrosion problem, yes, that might be a problem, but we haven't investigated in this study. But I want to say that with the fiber reinforcement, our cracking width will be very small. So we will kind of decrease corrosion, like chloride permeability, which as a result can improve the corrosion resistance of this specimen. But I think maybe in the future we will evaluate the chloride, the corrosion problem of the steel fiber reinforced cement mortar.
Thank you very much. The second question is from Sumaya Nasiri, and it's again two parts. She asks if the amounts of fibers are in percentage volume or percentage weight. And she's asking if the fibers were a replacement of portion of the sand or additional element.
Okay, so we did not, yeah. So first of all, it's by volume. So 1%, 2% is by total volume of the cement mortar, the total volume of the mixture, and we did not replace sand. We just added as a additional addition. We just added additionally. We still use the same volume of the sand, same volume of the cement, and the same of the water.